In today's lesson, we are going to look at interpreting statistics in the media. So we're going to be looking at kind of different situations that you may come across, and just kind of analyzing them. So the first one is brand comparisons. So a media advertisement made the claim in a recent side-by-side blind taste test, more people preferred Cool Cola over Choice Cola. So you might have seen these kind of phrases or statements made in advertising. So what questions can you ask to challenge or validate this claim? So what questions could we ask to see, is this claim actually true? Right? You may not be able to actually perform or get answers to these questions, but it might be something that you think about when you hear these statements. So you might think of something as, well, how many people did they survey? If they just surveyed one person or 10 people, maybe that's not a large enough sample size to really make this claim. So how many people did they survey? What were the actual numbers? So they say more people preferred Cool Cola over Choice Cola. Was it just one person more? Or was it 10, 100, 1,000? How many people preferred, or how many people liked each one? Or sorry, so we would want to know maybe the numbers for each product. What was the type of population? So who were they asking? So who did they ask? Were they looking at kids, adults, teenagers, right? Men, women, right? Who were they looking at? Was it anyone? Or like, who were the actual people that answered? Because that could vary. That could affect the choice. That could affect the preference, different taste preferences. Who carried out the study? Right, so who was the one that completed this study? Was it Cool Cola that completed it? Was it an independent study? Like who was the one who created and carried out the study? Because they may have an invested interest in the results. And maybe finally, were there similar tests? Did someone else complete something similar, or did they repeat this study? Or was it just a one and done type of thing where they did one study and got an answer they liked and finished it there? Did they repeat it? Were the results different? What were the results? Right, so different things you might want to think about when you hear kind of these questions. We can see some of these statements, right? So we have a bounty advertisement here, so 10 times more absorbent. Right, they're looking at 2 sheets of the leading ordinary brand and compared to 1 sheet. Right, so maybe there may be some questions here because this is an advertisement that they came up with. Doesn't your skin deserve better care? So this is looking at Dove. Right, one Dove just says this is care, the other one says it's harsher. So what are they referring to? Right, are they referring to the feeling, the cleanliness, the moisture? What are they using to reference, or what claims are they making? So a Tide ad, so don't pay for water, get 2 times the cleaning ingredients, so now more concentrated, versus the leading baking soda liquid detergent brand. Right? So again, what other statements? Right? It says they're more concentrated. If we read kind of the fine print, they're referring to the previous formula. So it may make it seem that it's more concentrated than other brands, but really they're comparing to themselves. Right? 2 times the cleaning ingredients. Again, who are they referring to? Right? What cleaning ingredients are they talking about? Right? So again, just different things to think about. Next example, the gross domestic product. So the graph shows Canada's real per capita gross domestic product, which is the total value of all goods and services by region in 2006. So we want to know what is meant by real, what are we referring to by per capita, and what do we mean by $1997 in this graph? So all in the title, what are we referring to in these things? Well, if we're talking about real, so in this case, real represents the value when effects of inflation have been subtracted. So real means we're not referring to inflation, we're referring to just the actual values, right? We've talked about how things could be inflated or inflation when we looked at the CPI in the previous lesson. So real represents the value without inflation. Per capita, we mentioned that before. Per capita means per person or per head. So we're looking at kind of an average. So we're looking at the GDP per person. So the total GDP of each place divided by the number of individuals or occupants. And then $1997, again, means the effect of inflation since 1997 has been accounted for. So we have taken into consideration. So the effect of inflation has been accounted for. And then B, describe what the graph shows. So what does this graph actually show? Well, it's showing the GDP per capita for each different region. Right? So it's showing the average value of goods and services per person in each region. In this case, the region would be Canada as well as the different provinces and territories. Finally, the last one, political polls. So we might see statements like this, especially when talking about surveys. So a newspaper reported this statement: the Prime Minister has the approval of 45% of the population. This is accurate to within 3 percentage points, 19 times out of 20. So we may see these statements or variations of these statements, maybe not so much in newspapers, but definitely in journal articles, reports, studies. We might see these statements. So what does it actually mean? Well, in this scenario, it means that if the poll were conducted "20 times, then in 19 of those times, so 19 of those times, the results would be within a specific range. And the results would range between 3 percentage points of 45%. So that means 42% to 48%. So if we completed this survey 20 times, or if we redid this study 20 times, 19 of those times, so pretty much almost every time, the results would range between 42 and 48%. In other words, you can also say, well, 19 out of 20 is the same thing as saying is equal to 95%. So we could say that we're 95% confident of results between 42 and 48%. So we're fairly confident that our results are going to be somewhere between 42 and 48%. So it just shows, again, how sure we are of our results. So those are the kind of the main things. The other things we're going to do is just kind of look at some examples of misleading statistics that are used in media, right? Take a look at graphs and maybe how they're presented, right? So again, I'm just going to go through and just show them. Again, this one here, the number of gun deaths in Florida. So it's kind of looking like after a certain law was enacted that the number of murders committed using firearms actually dropped. However, if you take a look at this graph, we can see that it's upside down. So even though that some points seem really low, if we flip it or rotate it, it's actually quite high. Right? So this was an actual graph that was sourced. It was an actual graph that was found. It is a commonly used one because of how misleading they're trying to make it. The next one looks at the top 5 counties with the greatest number of confirmed COVID cases. So this was in Georgia, from the Georgia Health Department back when COVID was going on in 2022. So we're showing the number of confirmed cases, and we have it going over time. So it looks like everything's decreasing and everything's turning out really good. However, if you take a look at it, in some cases it's not quite like that. We see dates interspersed. We see an April one down here at the end. So we see an April date down here. We see a May date down here. Another May date interspersed in between them. So it's not quite organized correctly. Right? It's organized, or at least here it's laid out to look like it's decreasing over time and everything's good by the end. In actuality, they've realized the mistake after it was already posted and sent out, so they did fix it, and this is actually what it looks like. So can you say COVID cases are going down? Yes, and on those specific dates, yes, but it's not as a consistent decrease as they seem. It actually increased after a specific while and then decreased. This next one, so this one is looking at the number of teachers and administrators in school, and as well as the student enrollment. So this graph is saying, well, over time, student enrollment in red, using the right or the left scale, has actually decreased quite drastically, while the number of teachers and administrators has increased. So you could see how people may use this graph and say, well, we don't need a lot of people, or we don't need a lot of teachers or administrators because there's more administrators than there are students. There's quite a lot more. Again, there's many things kind of wrong with this. You could look at the scale. On the left, it's going up by 10,000. On the right, it's going up by 1,000. So we're kind of exaggerating some increases here, right? Again, looking at proportions as well. So many different things that could be changed. If they were to change it, we might see something like this, where the values are actually kind of maintained, or have been kind of roughly maintained over time. Yes, there is a slight decrease in students, and there is an increase in educators and administrators, but we can say that it's not as drastic as the previous one showed. Right? So again, just different things to think about and to look at when we're looking at these kind of statistics. The last one is looking at the progress on lifting long-term drinking water advisories on public systems on reserves. So looking at in general, I think primarily indigenous communities. So looking at these water advisories. So we started off with 106 water advisories in 2016. By 2018, we were down to about 75. And then they're predicting that over the next 3 years, it's going to drop drastically to 0. So that in March of 2021, all long-term drinking advisories will have been lifted. So again, this one, nothing is too wrong with the data or the scales. Right? They both start from 0. They both seem to go up by a proportionate amount. The graphs are slightly different from the actual lines. The biggest thing might be how they're getting their prediction. We look at this kind of line here at the end. It seems to be a pretty consistent line. If we look at the trend before, though, it wasn't that drastic drop. It took 2 years just to go down 30. They're saying after 3 years, we're going to go down 75. Right? We're going to decrease from 75 water advisories to 0. Right? So here, I would question how they're getting this data, why they're predicting that such a large drop is going to happen or occur. And you could probably do the research and check now and find that there are still drinking advisories in existence in Canada. So their prediction is false. So there must be something, or there probably is something wrong in their estimations. Or maybe other things happened. Maybe things occurred that they didn't account for. And if it did, why didn't they account for it? Right? When we're dealing with kind of situations like this coming straight from a government website. So again, the main thing from this lesson is just to really just ask questions, right? Don't just take statistics. Don't just take things that are given to you in the media or in general from anywhere as truth. Right? Question it, think about where their information is coming from. You can talk about the sources of the information, how they got the information, how they completed the study, different things like that. So again, just the biggest thing from this is just ask questions.